so this is paper is not about novel. It's about faster. And I just heard that it's frustrating when things are slow. So this is also a nice paper because you have heard about the clinical application. You heard about a preclinical study. And this is about technology. This is about engineering. And I think this highlights what is unique about this journal and also what is unique about this society. Right? So then, so here the reference for this paper is the commercially available microscope, confocal microscope, which is Vivascope. You may know it. So everything the authors are referring to in terms of better, faster, is relative to the commercial Vivascope, right? And then, so the new thing is not only faster, but they're also working at different wavelengths. They're working at 1251 nanometers to 1342 nanometers, and the current Vivascope is works at 840 something nanometers, right? So this is let's see, yes. So this is a nice schematic, just showing you how things work at a very high level. So this is what would be in the box, right? And then this is the handpiece. And it's just showing that there is a source, then it's just lenses, split the beam, and then you send the light to probe the skin. And then the light comes back, and then you have a detector here, right? And then he's just showing you the inside of the probe, which again is very nice work, very elegant. But it's also highlighting, this was done at the lab, at the Gary Tierney lab. And when you look at this, it's pretty nice actually for a lab to do this kind of prototype. So what is allowing this, like going faster, going this kind of prototypes, is just how technology advances. 3D printer is cheaper, easier, faster, more precise. And then also optical components are cheaper and smaller. Right? So then just putting it together very nicely. Right. So here's the result. So you can see here in panel A, the depth is 50 micrometers, and you can see, here keratinocytes, and you can see the white around them. That's about the size of the cell. The scale bar is 100 micrometers, so 10 of that is about 10 micrometers, which is about the length of a cell. And then you go deeper, and here in panel C, what they show is, with the arrows, is fibers. And here we have in panel D just a cross-sectional vision after assembling a lot of images. And again, you can see here the stratum corneum, the epidermis, the dermis, epidermal dermis junction. Here in dark is a blood vessel, and then more collagen fibers. Now, it's not only 10 times faster, it's also the probe is smaller relative to, again, to the commercially available Vivascope. And then they argue that confocal microscope, even though it is available and there are CTP codes, it's not widespread use. And then if this is going to be enough to make it more widespread use, that's a question for you, the users. But the other thing that this allows to, which they haven't explored yet, is that they can go deeper at these wavelengths, deeper than 800 nanometers. So I think there's more to come from this group, and I think this is, again, this is very exciting. And thank you.